It's called chain rule, which that doesn't give anything away right away. We're going to do this for a couple days, today and tomorrow. And then next week we'll have a quiz on Wednesday on these two sections. So chain rule is all about composites. So do you remember last year, Algebra 2, pre-calc, f of g of x, where you would put functions within a function? This rule is for composites like that. So when we have a function like that's kind of complex, this rule will help us out. So what I'm going to do, like I have for the other rules, I'll write it out in its calculus notation, and then I'll give us a little saying as well. So the rule for chain rule, if we're asked to find the derivative of a composite, so f of g of x, it's going to be f prime of g of x times g prime of x. And then I'll write the saying. I'll let you get it all copied. Bless you. Bless you. Calculus. And the words won't make sense right now, I know. I'll explain them. So for composites, when we have the f of g of x, f is the outermost, and then g of x is our innermost. And so when we go to say this saying, we'll have to pick out what's outer and what's inner. And so just to kind of get our bearings on that, before we even try the derivative, we're going to make a chart and practice like figuring out what the inner and the outer is. So I'm going to have 4 columns to this chart. We're going to have a column that says non-composites, a column that says composites, a column that says inner, and a column that says outer. And we'll just kind of practice picking out the pieces first before we try the calculus with it. Okay, so a non-composite, something that's not like 2 functions at once, would be something like y equals 3x squared plus 6. There's really nothing too fancy about that. Pretty standard equation. That would not be a composite. Bless you. But if I take it and change one little thing, now, oh my goodness, we're at like 6, 5 maybe. So if I change it one little way and make it to the 7th power, now all of a sudden it's a composite. There's like multiple pieces going on to this function. And so what we're going to have to do in order to figure out the calculus you can take the box if at this rate. Everybody's listening.
like every time I blow my nose, I get scared that I stumble my way afterwards.
We would tell you.
I know, but that's how it's like obviously you don't want to walk around with like a booger on your face, but it's so nice when someone's like, you got a booger.
All right, so now the inner part, most of the time, it's just what's in the parentheses. That's an easy way most of the time to think about it. So the inner part to this would be 3x squared plus 6. The outer part, so the biggest part of this function would be the 7th power. We can't put x to the 7th because we're already using x. So what we're going to use is a u. So something being to the 7th power is what the outermost function is. So that's what we're going to practice. So let me give you another one. Let's put y equals the sine of x. Okay, even though it's trig, it's still pretty standard. Nothing crazy about that. But if I change it and make it y equals sine of 6x, now it has multiple things going on. And so think, like if you were going to put parentheses somewhere in this problem, couldn't it kind of be natural that parentheses could go right there? Then that will help you find your inner part. The innermost part is 6x. And that means the outer part is sine, but it has to be sine of something. So we're going to put sine of u to represent that. Okay, let me do this one. Y equals x squared plus 1. Again, nothing too fancy, just kind of normal. But if I would do y equals the square root of x squared plus 1, then it becomes a composite. The inner part is x squared plus 1. And the outer part is the square root part, so we'll do square root of u. And if you want, you can also write it as a 1/2 power, either way. So today, when we go to derive, before we derive it, we'll be picking out the inner and the outer, so we can do this formula. Okay, let's actually derive one now. Let's go ahead and do one. I'm going to do one kind of like the green one. If they ask us for the derivative of, let's make it 7x to the second plus 4 to the 5th power. That's what we'll derive. Okay, now, especially when you begin, I suggest actually writing out your inner and outer. So kind of what I do is I put just a little I and an O for inner and outer. Our inner, pretty easy to pick out with the parentheses, is 7x squared plus 4. Our outer is u to the 5th. Okay, now to take that saying and kind of dissect it. We're going to take the derivative of the outer. So if I just had on a piece of paper, what is the derivative of u to the 5th? What would your answer be? With the shortcut power rule, what's that going to be? U to the 5th. Five u to the 4th. Okay, so the chain rule says take the derivative of the outer, but keep the inner. Here's what it means. You're going to bring the 5 down, and you're going to have a 4th power, but we're not going to use the u. We're going to keep the inner part there. So we're using the rules to take the derivative of the outer part, but you still keep the inner part within it. So take the derivative of the outer, keeping the inner, times the derivative of the inner. So now we look at our inner and we just want to find the derivative of that. And the derivative is 14x. And there's our first chain rule. That's how we're going to do composites. All right, I'm going to give you one, even though we're just 2 in, I'm going to give you one to try. I promise it'll be the same level. I promise. I promise no evil right now. Right now. Maybe in the future. Like maybe in 5 minutes. All right, try this one out. Good, good. All right. So we're getting used to it. Okay, now let me do this little change. We'll do this one together. Let's find the derivative of who volunteered a while ago to do the long way every time we did the short way? Was it Kylie?
No.
No.
It was alright.
What a shame.
We don't have to do it that way.
Yeah, or it would be like our last problem of our life. I know, yeah. Okay, so we take the derivative of the outer. So we bring the 300 down, keep the inner, and then to the 299th power times the derivative of the inner. So that's going to be 8x plus 10. Okay, now, as it's written, it's wrong. In terms of symbols, how do I need to change how I wrote this? Any ideas? Yeah, so that whole inner part needs to be in parentheses. The reason why it didn't before is because there's only one thing, but now that we have multiple things. So just be careful on that. Okay, now, maybe start to get a little bit evil. We're doing this together, but it's gonna start looking a little bit different. Okay, here's why this one's evil. Do you see the parenthesis part? Like there's an inner and an outer, but there's also division. So technically, this could be a mixture of rules. This could be a quotient rule and a chain rule. But I'm going to show you a way out of that. So you know how sometimes like we've bumped things up and we've like made the exponent negative? Let's do that. Let's rewrite this and bump the bottom part up. So if I bump the bottom up, it'll be 2x minus 3 to the negative second power. When I do that, now I got rid of the quotient rule. So now I can just do chain. The inner part is still going to be that parenthesis part. So the inner is still going to be 2x minus 3. The outer is like everything else. So the outer is going to be negative 7 u to the -2. So everything but that inner part. And then we'll do chain rule like we have been before. So if we had to derive -7 u to the -2nd, we'd bring our power down. So -7 times -2 is 14. Keep the inside. And then subtract 1 from the power, so -3. So that's the derivative of the outside, keeping the inside, times the derivative of the inside. But we have a negative exponent, and we need to fix that. So we're going to take this part right here and bump it down to the bottom. So what's left on the top is a 14 times a 2. So I'm going to make that 28. And then on the bottom, I'll have 2x minus 3 cubed. And there would be my answer. Okay, now we're going to go and do like several trig examples. Practice this with trig. So let's try first. We'll find the derivative of, let's do the cosine of 10x. So the innermost part is going to be that 10x like we talked about in the chart. So our inner is 10x. Our outer is the cosine of u. So derivative of the outer, derivative of cosine is negative sine. Keep the inner times the derivative of the inner. And that would be our answer. Technically, if this helps you make sense of what's going on with the trig, this 10 isn't really part of the sign. So if you write it like this, it might make more sense for like when we work with this later on. Just kind of bring that constant to the front. Okay, I'm going to do one very similar, but I'm going to change the trig. I'm going to make it the secant of 37x. Okay, so for this one, again, it's kind of easy to pick out your inner. If you think where the parentheses would be, the inner is 37x. The outer is the secant of u. Okay, now you can remember or look back in your notes. But what is the derivative of secant? Oh, I have your notes, don't I? They're held captive. Secant tangent. So here's what we have to be careful of. It's secant of something, tangent of something. So when we do the derivative of the outer, keep the inner in both parts. So when it has that double part, secant and tangent, the inner needs to be in both parts. And then we're going to multiply by the derivative of the inner, and I'm just going to stick it in the front. So it's like that. So those are the ones to be careful of when their derivatives have two parts. Okay, now, are we doing okay? Okay, I'm going to switch up the trig in another way, and I got lots of trig. Let's make it sine squared of x. Okay, now do you remember how another way to write this is sine of x squared? So the reason why this is different is when you think about where the parentheses are, this time the trig is the inner part. So when we go to set this up, the inner is the sine of x, and the outer is u squared. And then when we derive the outer, u squared, bring the 2 down, keep the inner, times the derivative of the inner. And there's our derivative overall. Okay, I got another one I want to do. Well, I got a couple more, but this one for sure get in. Let's do the derivative of the square root of, let's do the square root of tangent. So if you think about the parentheses, this is technically like tangent of x to the 1/2 power, which means the inner is the tangent, and the outer you can either write square root of u or u to the 1/2. It might be easier to think about the derivative if you change it to the 1/2. And then we'll derive the outer. So bring our 1/2 down, keep the inner to the negative 1/2 power. So that's the derivative of the outer, keeping the inner, times, all right, now we got to remember tangent's derivative. Secant squared. The co's are the negative ones. Secant squared. And then this part has the negative exponent, so this part will bump down. And since 2 is in the denominator already right here, it can be written as secant squared x over 2 times the tangent of x to the 1/2 power. And if you want to make that a square root, that's fine too. Still feeling okay? Okay. I think we're going to stop there for today. It's a good... Because I think that's a good halfway point of the lesson.